Good morning, still to everybody that is in the Central Time Zone. And my name is Brittany Collier. I am the Education and Outreach Director for Arkansas NSF EPSCoR Central Office. Welcome to the Career Development Workshop. Thank you so much for being here. We are all really excited to hear Jory Weintraub talk about science communication. I know that a lot of people have really been excited about this presentation, and this is so important now, as we all know. So before I let you take it away, I am going to give you the introduction of Jory Weintraub is the Science Communication Director and a faculty member with the Duke Initiative for Science and Society at Duke University. He teaches science communication courses for undergrads and graduate students and runs science communication training for faculty and postdocs. He received a PhD in immunology from UNC Chapel Hill and transitioned to focusing on science outreach and science communication full-time after being awarded an NSF postdoctoral fellowship in STEM education. He has 25 years focusing on STEM outreach, STEM communication, faculty development, and DEI efforts. We are so glad you're here. Thank you so much. And I will give you the floor.
Thank you so much, Brittany, for that nice introduction. And thanks to Jennifer Fowler, who I think is calling in. I think she said she's on the road, but is calling in. Jennifer was the one who first reached out to me and invited me to join you. And this is my second or third workshop I've done with Jennifer as part of the extended Arkansas EPSCoR community. So I'm really pleased to be here once again. It's been a couple of years though, I think. So I'm guessing that most of the people on this call are probably people who haven't been through a workshop before. But I'm really pleased to be here. As Brittany said, I'm trained as a scientist. My PhD is in immunology. It's been interesting for the last couple of years because I've been telling people that 25 years ago when I was getting my PhD in immunology, I never for a second ever dreamt that I was working in a controversial field of science. It seemed that there was nothing controversial about vaccines and immunology back then. And lately I find that my background has opened me up to all sorts of questions from people who are questioning things like the safety and efficacy of vaccines. So of course, I'm happy to share what I know based on my study of immunology. But after graduate school, I transitioned away from bench research. And since then, most of my career has focused on science communication and science outreach. And that's what I'm here to talk about today. By the way, my contact info is on the screen in front of you, jory@duke.edu, very simple email address. And you are free to reach out to me if you have questions after this, or if you would like a copy of my slides, I'm happy to share them with you. Just reach out by email and I will send you those slides. Now, I just want to sort of say as a preface that I teach semester-long courses in science communication. And so, that obviously covers a much wider range of topics that I'm going to be able to do in 1 hour today. So this will not be a comprehensive overview of all things science communication, but I will hit on some basic points. What Jennifer Fowler asked me to really focus on was the importance of coming up with an engaging title or summary, short one-sentence summary of the work that you're doing. And, I thought about how I was going to do that. And I thought I really need to take a step back and cover some basic concepts of science communication. So I'm going to cover some important introductory points, and then we're going to really bend that towards looking at ways to craft concise, engaging titles. So that's what we'll be working on today. If you have questions at any point, I encourage you to put them in the chat room. I have the chat window open. You are also welcome to use the electronic hand raising device, which is on the menu bar at the bottom of your screen, and you can raise your hand that way. And I have the participant window open, so I will see hands raised if you have questions that way. So please feel free to stop me at any point if you have questions or comments or would like to add something to what I've already said. And if the screen on the title slide here looks blurry to you, that is the point. This is sort of a typical generic science poster, one of the places you might find a science title. As I said in my description of the workshop, the title could be a title for a poster, it could be a title for a paper, it could be a title for a talk. It could even be coming up with a concise title for an entire project on a grant proposal or an annual report or something like that. The same concept applies to all of these things. It's a concise way of summarizing what it is that you do and why it matters. And so I wanted to have sort of a generic poster here, one that I would actually say is the kind of poster you probably want to avoid if you're doing a poster session, because look at all that text, right? There's so much text, it would take a half hour standing there to read all of that. And more we're moving towards less text, more visuals and engaging images, and encouraging people to interact with the presenter or the poster as opposed to standing there reading text. But I sort of wanted it as an innocuous background just to sort of set the stage and really get my title across to you, which is Crafting the Killer Title, the Importance of Messaging in Science Communication. All right, so I see Toby getting the ball rolling there with the question. Great. So what about a snappy title? This seems to be a divisive issue that varies by field and advisor. It's a great question to start with, and it's certainly something we're going to be talking more about. My response to that, because I get this question a lot, is this comes down to a matter of personal preference. I like snappy titles. I like titles that are a bit pithy and that are engaging, and we're going to talk all about that. And I'm going to give you some examples of ones that I really like. But I always put an asterisk by that and say, especially, if you are a graduate student, for example, and I saw from the introductions that many people on this call are graduate students, you need to get to know your audience just as any other presenter of science does. And in the case of grad students, for example, or undergrads, if part of your audience is your advisor and your advisor doesn't like pithy or snappy titles, then you probably need to find a common ground so that you don't essentially, ruffle the feathers of your advisors. Having said that, I personally, for students that have worked for me, encourage them to be creative. As long as you're respectful, you're not offensive in any way. I think anything that is creative and clever and still communicates the message of your work is going to stand out and is going to get you noticed. It's going to get more people to come to your poster. So we'll talk more about this, but ultimately it comes down to personal preference. And for me personally, I've always encouraged my students to try to be creative and interesting with their titles. But really, you need to know your audience and who they are. Speaking of audience, this first slide sort of gets at that, which is that if this slide resonates with any of you, you are not alone, right? This is something I just grabbed this off of Facebook or Twitter or something, but it just seems so perfectly relevant to the things I talk about in my science communication workshops. Right. And so if this resonates with you, then you are, as I said, in good company. Many of us who are trained as scientists and engineers have had this experience of talking to friends and family, and they nod their head and they smile and they seem very impressed with what we're doing. But we get the sense that they don't really quite get it. And that's not their fault. That's really our responsibility as the person doing the work to communicate to them in a way that they can understand and that they understand the meaning and the relevance of what we do. But, if this resonates with you, then as I said, you're not alone. Scientists and engineers have developed a way of communicating with each other over hundreds or thousands of years that works because it's the way that we're trained as scientists. It works for us within the science community, but it almost always doesn't work as effectively when you're talking to anyone outside of your immediate science community, any sort of non-expert in your work. And that could be the general public, it could be friends and family, it could be policymakers, it could be the media, it could be K-12 students and teachers, it could even be other scientists who happen to work in different disciplines. And because we're seeing science and engineering becoming so much more cross-disciplinary these days, it's really important that we not assume that just because someone has PhD after their name, that they're going to understand everything that you say. So, this is really a starting point for us, is to realize that we have this way of communicating with each other as scientists, but it's a way that doesn't necessarily work for people who are non-experts in the field. All right. So the first thing people typically see is the title, whether, as I said, whether it's on your poster or whether it's on your paper, whether it's on a grant proposal, they see the title or the headline, essentially, of your work. And that's what we're really going to be focusing on today. But a lot of the principles I talk about with titles and headlines, of course, apply to all aspects of communicating your work. And hopefully you're having a chance to read some of these. These are all real headlines from real articles that have been published. And they're for your entertainment, but they're all out there. They're all real. Just out of curiosity, I would love to have you put in chat which one you like the best of these. So I've numbered each one of them. Feel free to put your favorite one, just list the number in chat. And I'm always curious to see which one is the most entertaining, amusing for the various people who are watching. But it really begs the question, what is the purpose of a title or a headline? What is it meant to accomplish? And I'm looking at the results as they're coming in, and it looks like, as you might expect, there's a lot of diversity in responses. 5's coming up, 2's coming up, a lot of them. I think 2 is my personal favorite. There's a 1 in there. So yeah, feel free to share your favorite of these headlines. But what's the purpose? What is a title or a headline of a project meant to accomplish? What is its goal? Well, there are several things that it needs to do. First and foremost, it needs to draw people to your content, whether it's a poster up on a big poster board at a conference, or if it's an article in a journal or in a magazine or in a newspaper or online, or if it's the title of a grant proposal, any of these things. The title is meant to draw people in and to get them interested in what you have to say. As I said, the title is the first thing people see. And so if that doesn't grab the readers or the viewers' attention, you've lost them before they've ever gotten to the content, right? So it needs to lure people in. It needs to draw them in. It needs to serve as a translation, because remember, whether it's a poster or a grant proposal or whatever it is, the odds that every single member of your audience already understands the discipline thoroughly and has the exact same shared vocabulary with you, those odds are pretty slim. So it's likely that people are not going to be familiar with all of the jargon of your field, depending on who your audience is. And so the title has to serve sort of a translation purpose as well. And then finally, the title may be serving a persuasive purpose. So again, if it's a poster or a talk title, you're trying to persuade them that this is relevant and interesting to them, and that they should take time to come up to your poster and take a look at it and talk to you, or take time to come to your talk and listen to what you have to say. Or if it's a grant proposal, that you want to persuade them that this is important, compelling, fundable work, right? So in every one of these cases, there's a sort of drawing them in, there's translating or clarifying what it's about, and then there's this persuasive piece. And all of those things are really important components of coming up with a title that's going to grab people's attention. All right, so where do we start with this? This is a big task, and I don't want to seem like I'm putting too much pressure on the process of coming up with the title, but it is important. So where do we start with this? Well, I like to start with one of my personal favorite science writers of all time, a gentleman named Tim Radford. Some of you are probably familiar with Tim Radford's writing. He wrote for The Guardian. He was the science editor for The Guardian for many, many years. And he's a fantastic science communicator, science writer, science journalist. And he has this great article, which is his manifesto. He calls it the Manifesto for the Simple Scribe. And he says it's his 25 commandments for journalists. And again, journalists are writing for more of a general public audience, but everything he says in here applies to you, whether you're communicating to the public or whether you're communicating to your scientific peers. So as we go through and we look at some of these strategies that I'm going to share with you, I'm going to be citing from time to time the commandments that Tim has put forth that are relevant to that particular concept. And so the first one, this is sorry about that. I seem to be going in the wrong direction there. The first one is, it's actually number 10 for him, but I'm starting with it, is the following. He says, here's a rule. A story will only ever say one big thing, okay? Every story, every poster, every paper has to have one main message. And then he goes on to say, well, if there's 4 strands of a tale, right? Typical science project is going to have lots of collaborations and lots of side projects, but those are strands of the tale, right? But there has to be one big overarching thing to say. And that's what in the science communication business we refer to as your message. So what is your message? What is the point of the work that you are sharing, right? The goal of science communication is to help people understand what you did and why it matters to them. And that needs to be captured in the message, okay? I often compare your message to the headline of a news article, right? It's the 7 or 8 or 10 words that summarize why this matters, what it's about and why it matters to your reader. And if you can't use those 7 or 8 or 10 words to get the reader's attention in clear, simple language and let them know what this is about and why they should care, then whether they're at a poster session at a conference or scrolling through a science news website, they're just not going to stop and pay attention. So, you know, I am putting a lot of pressure on this message, and it's not an easy thing to do, to come up with that concise 7 to 10 word summary that really gets across this idea of what you did and why it matters. But it's essential that you put a lot of effort into this, because this is the first thing they'll see, right? So your message needs to be easily understood. It needs to be memorable. You want this to stick with people. It's really pointless if they're interested for 30 seconds and then it instantly leaves their head and they don't take away any sort of long-term message. And perhaps the thing that tends to be most challenging for a lot of us as scientists is that you want your message to stay focused. And the reason I say this is most challenging for a lot of us as scientists is that, as I said, we do lots of different things. We do have multiple collaborations going on at a time. We're never just focusing on a single scientific question, and we get excited about all the work that we do as scientists, and we want to share all of it. And a lot of scientists have a tendency to try to share all of it in their opening sentence or their headline or their title, right? You can't summarize 25 years worth of work in 7 words. It's just not possible. So you need to stay focused. What is the message that you want to communicate with this particular body of communication? Again, whether it's a poster or an article you're writing or a blog post or a grant or whatever it is. So a message should be understandable, memorable, and focused, okay? So that's a starting point for us. So let's talk about how you craft a good message. Well, this next point is so important to Tim that he actually has a couple of commandments on it. And one of them he lists as his first commandment. So he says, when you sit down to write, there is only one important person in your life. This is someone you will never meet, called a reader. Now, he's writing from the perspective of a journalist here. If you are coming up with a poster title, you will meet this person, and they're not called a reader, they're called a conference attendee, right? And hopefully you will meet them because hopefully they'll stop at your poster. But you get the idea, right? The most important person in your life when you're coming up with that poster and with that title is the conference attendee or attendees that you want to stop at your poster and talk to you about your work, or you want them to attend the session where you're presenting your work, right? So you need to keep that audience member or those audience members in mind. They're the most important people that you will interact with or communicate with. And the other commandment along those lines, I love this one. Commandment number 7, he says, if in doubt, assume the reader knows nothing. However, never make the mistake of assuming the reader is stupid. Big difference there, right? And he goes on to say, and I think this is just such a wonderful line. He says, the classic error in journalism, and I would say classic error in science communication, is to overestimate what the reader knows and underestimate the reader's intelligence, right? Now, clearly, if you're putting together a poster for a scientific conference, you know that everyone who's attending is going to be an intelligent person, but they're going to be coming from all different subdisciplines and across multiple different disciplines, depending on the meeting you're attending. If you're putting together a poster for the AAAS conference, you're going to have, every possible flavor of scientist and engineer, social scientist, right? It's going to be a huge potential audience, right? And so do you want to just speak to the other people who do exactly what you do? Or is your message important enough that you'd like to get people from all of these other disciplines to stop and talk to you about your work, right? So don't ever underestimate their intelligence, but know that, they're not going to probably have the same vocabulary that you have. So it's really important to keep that in mind. All right. And so, my way of communicating that to you is to say, know who your audience is and frame your message for that audience. And what do I mean by framing? Well, let me give you an example. Framing is the context in which you deliver your message. Okay, so if you're invited up to DC to meet with some policymakers and talk to them about your research, you're going to want to frame your message in a context that's relevant to those policymakers and, importantly, to their constituents, right? So, you may frame your work in the context of, here's how, basing policy on my research could save, hundreds of millions of dollars a year in healthcare costs. Here's how policy framed or based on my research could lead to, cleaner drinking water for people, across the United States, right? So put it in a context that's going to be relevant for them, right? Now, if your audience happens to be a classroom full of third graders, maybe your next door neighbor is a third grade teacher and they invite you into their classroom to talk about what you do, third graders aren't going to care about health care dollars or, policy implications of your work. So, your title and your framing of your message needs to be reframed. The message itself doesn't necessarily change, but the context in which you deliver it is going to change based on who your audience is. So remember Tim's commandments about how important your audience is, and, put a lot of thought into who your audience is, who you want your audience to be. Again, if you're going to a conference and there's going to be a diverse array of scientists at this conference, do you want your poster to be one that only the people in your very sub field of your discipline are going to stop and look at it? Or are you looking to find collaborators across different disciplines, in which case you're going to frame it so that it's more relevant to a broad range of people? So thinking about your audience and framing for your audience is really important. The next thing Tim talks about is, what do you leave out? And I love Tim's response here. He says, the crude answer is everything he possibly can, right? So, the bottom line here is, you want to be as concise as possible. And this is absolutely, positively true for certain with the title, right? Because you have a limited amount of real estate space, whether it's on a poster title or a paper title or a headline of a blog post that you're writing. So concise always wins the day. You're always trying to be as concise as possible. And in the interest of not being hypocritical, that's all I'm going to say about that point. All right, next commandment from Tim is an important one. They're all important. And this gets at the heart of communicating effectively to diverse audiences. And he says, beware of long and preposterous words. Beware of jargon. If you're a science writer, this is doubly important. If you're a science writer, you occasionally have to bandy words that no ordinary human would ever use, like phenotype or mitochondrion or cosmic inflation or Gaussian distribution or isostasy. So you really don't want to be effulgent or felicitous as well. So he's clearly having a lot of fun with this commandment, right? But the point is clear, which is avoid jargon. And let's do this in a more concise way. English is better than Latin. You don't exterminate, you kill. You don't salivate, you drool. You don't conflagrate, you burn. So this is all about avoiding jargon. Now, again, kind of like the question that I think it was Toby posed at the beginning, about should you go for sort of witty and pithy, or should you try to be, some people may not sort of be down with that, right? I think jargon is another one of those areas where my feeling as a science communicator who's trained as a scientist but does science communication is that no matter who your audience is, you can always benefit from using less jargon. Even if you're talking to your scientific peers, right? It's okay to try to trim out some of the jargon. Now, jargon does have a purpose, right? It's efficient. You could say we are going to perform some gel electrophoresis, or you can say we're going to run a gel. And anybody who's set foot in the lab knows what you mean when you say run a gel. But if you're talking to someone who's never been in a lab before, they have no idea what that means, right? So it's an efficient way of speaking, but only if people have that shared vocabulary with you. And so if you're trying to reach an audience beyond your immediate field, then the less jargon you can use, the more likely they are to understand. And it's important to realize with jargon that it's not always big, long, complicated polysyllabic words, such as polysyllabic, right? It could be very short, simple, everyday language, but used in a discipline-specific way. And so the example that I always use for that is a simple word. We all know it. We all use it. 3 letters, the word law, right? When we talk about a law, as scientists, as engineers, we think about something like the second law of thermodynamics, for example, right? And, a law to a scientist is something that has a very defined, precise meaning. It's something that's based on hundreds or thousands of years of observation and analysis of information and collection of data. And it's this very sort of almost fixed and rigid, unchanging thing, right? The laws of thermodynamics apply whether you're in Arkansas or North Carolina, like I am, or Paris, France, right? The laws of thermodynamics apply everywhere you go. So there's this very sort of notion of this very sort of fixed, rigid meaning of a law to a scientist. Now, if you ask an attorney, what's a law? Your answer is going to be very different, right? Oh, well, a law is a rule that we just sort of make up on our own as a society. And then, sometimes we vote on it. We get the public to decide if it should even be a law or not. And, it's not universal. I mean, it changes from city to city, from state to state, from country to country. So, a law is very flexible. It's very malleable, right? That's a very different meaning of the word law. And it doesn't mean that attorneys are wrong and scientists are right, or vice versa. It just means that we use that word in a different way, okay? I have a son who's an aerospace engineer, and I have a daughter who's in her second year of law school right now. And I guarantee you that they use the word law in different ways when they think about that word, right? So it's really your perspective, but as you're communicating to an audience, you need to think not only about how you intend for a word to be interpreted, but you need to think about who your audience is and how they're used to using that word. If you're speaking to a room full of lawyers, then when you say the word law, it's going to have a different framework and a different meaning for them. So it's important to remember that jargon is not just big, long, technical words, but it can be simple, everyday language that's used in a discipline-specific way. No matter what, you want to try to trim that jargon out. So let's do a little audience participation here. So I would love for people to type into chat their translation for me. I'm going to give you some jargon, something the way a scientist might say it. And I would love you to sort of de-jargonize that or translate that for, an everyday audience. All right. So for example, a scientist might say something like, to conduct a study that will help determine. All right. That's a very sciencey way of saying something. What are we really doing there? What's a much better way to say that? Put your thought in chat. I'd love to see what you can come up with. Study. Great. Other thoughts? Try to figure out, experiment. Good. Yeah. So what did I have? I had to study. Yeah, there you go. So it's about, remember, being concise and being acceptable. Come up with a new rule. Great. Wonderful. So yeah, being concise and being acceptable. Okay, let's do another one. Elucidated the mechanisms by which. Okay, very sciencey thing to say. I have a colleague here at Duke. He's a science writer in the news office. And he always says, the word elucidated only exists on college campuses. But how would you say this to an everyday person, right? Elucidated the mechanisms by which. Figured out, showed how. Yeah, exactly, right? Showed how. Just keep it nice and simple and accessible. Or how about this one? If any of you have ever written a grant at any point in your life, which I'm sure most of you have, I guarantee you that at some point you have said that you will foster interdisciplinary collaborations, right? You're guilty of it. Come on, I've done it. We've all done it. What are we really talking about? What are we doing here when we foster interdisciplinary collaborations? Exactly. Work together, work well with others, play well with others, work with teams across departments. Yeah, it's exactly. I had build teams, but yeah, you get the idea, right? It's simple, accessible language, right? The goal of science communication, whether it's coming up with your title or writing your paper or whatever it is, giving a talk, the goal is not to convince people that you're smart. You've already won that fight, right? People already think you're smart. You're scientists, you're professors, you're PhD students, right? People already think you're smart. You don't need to use that language on the left side of the screen to convince them that you're smart. They already think you're smart. The goal of science communication, as I've said already, is to help people understand what you do and why it matters to them. And so that language on the right side of the screen, that accessible language, is actually going to be more effective at that. In fact, they've done lots of studies where they expose non-scientists to the kind of language that you see on the left side of the screen. And they ask people, what's your perception of the person who said that? And usually what they'll say is, they seem really smart, but I don't know, sometimes they'll even say, sometimes people like that kind of seem snooty to me. They think they're smarter than me. They think they're better than me. It can have this off-putting effect. So people might think you're smart, but if you use language that they don't understand, that's not accessible to them, it may also have them feeling a little bit, it's a bit off-putting, and it may make them feel like you want them to feel like they're less intelligent, which you certainly, I know that's not your goal, but that's sometimes the effect when you use the kind of language that you see on the left side of the screen. So using simple, accessible language is crucial, right? And we do this all the time. We even do it with numbers. And in fact, numbers are the coin of the realm. It's what we live in, right? We're scientists, we're engineers. We are all about numbers, right? Numbers define us, right? So, but again, we use numbers in a very jargony way. It's what I call number jargon. So, for example, we may say something like 48.95% with a p-value of less than 0.05, blah, 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 right? That's the way we might report a number as a scientist or an engineer. What's a much better way to say that when you're talking to, I don't know, Uncle Bob, the plumber, right? Someone who doesn't think about numbers and statistics all day. How would you give that number in a much more accessible way? Go ahead and put it in chat. About half, exactly, about half. I think that's exactly what I had, about half. Now, is about half as precise as 48.95%, blah, blah, blah? Of course not, right? We know it's not as precise, but when you're talking to Uncle Bob the plumber, he doesn't need that precision. He doesn't need the p-values, right? Within the science world, we can't even decide what p-values mean anyway, right? We debate what they mean and their value, right? So just about half is perfectly fine for a general public, non-expert audience, right? It's the way that you communicate to people who don't live in at the fifth decimal place, right? So about half, perfectly fine. The other thing is, we could repeat this experiment 1,000 times. We're never going to get 48.95% again, right? We're going to get 49.32 and 47.96. And, so about half, perfectly fine, perfectly fine. All right, what about this one? 32 million Americans, right? Who can really wrap their head around 32 million of anything? It's a number that, our brains aren't made to wrap our heads around numbers like that. And we're seeing lots of big numbers these days with COVID and being in the middle of a pandemic, right? But it's hard to make sense of that, right? So what's a better way to say 32 million Americans? And I'll give you a hint. There's about 320 million people in America. So how might you say this to Uncle Bob the plumber? Okay, 10% of the US population, that would work. Although to me, percent still sounds kind of mathy, right? Let's try and make it, is there a way to make it even simpler than that? 1 in 10, exactly, 1 in 10, right? We can't picture 32 million of anything, but we can easily picture a room with 10 people in it and understand, the concept that one of those 10 people might get a breakthrough COVID infection, right? That's the kind of number that we can wrap our head around. So when you're trying to communicate these numbers, put them in a context that's easy for people to understand. Here's one you see all the time, common mistake among scientists, the metric system, right? So they'll say the largest dinosaurs had brains about 8 centimeters in diameter. But this is the US, which means that most of us have no idea what a centimeter is to begin with, right? Or maybe we know, we'll say, oh, wait, centimeter, 2.5 centimeters to the inch. So, divide by 3 and carry the 12 and, whatever. But what you're asking them to do is you're asking them to do math in their head, right? And nobody wants to be, unless you're maybe a mathematician or an engineer, most people don't like to be asked to do math in their head. So what's a much better way to communicate the size of a dinosaur brain? Tiny brain, certainly. Size of a peach, great. Yeah, put it in the context of something that people can relate to. So I had about the size of a baseball. I realized that that's actually not even the best example, because that might work here in the US where people are pretty familiar with baseball. But if I were doing that in a country where they don't really play baseball much, that wouldn't have as much meaning, right? I don't know how prevalent peaches are around the world. Does everyone everywhere know what a peach is? I feel like probably people know peaches better than baseballs, maybe not. If you really want to be safe, but you still want to give them an estimate, I suppose one thing you could do is say about the size of your fist. There you go, Brian, perfect. Because everyone has a fist, right? No matter where you are, no matter what kind of fruit you grow or sports you play, there you go. You get the grand prize. You get a peach and a baseball, Brian. But yeah, exactly. You want to put it in a context that makes it easy for people to understand and picture what you're talking about, whether it's numbers of Americans or the size of a dinosaur brain or whatever it is. So it's all about avoiding that jargon. All right, so here's a little tool, a little trick for you if you want to get a sense of how jargony your language actually is, right? So there's a free tool out there. There's actually a few different things like this, but I'm going to give you this one today. It's the dejargonizer. It's freely accessible on scienceandpublic.com. And what it is a text editor. You can put in any text you want, and it will sort of run, it'll run through sort of, it'll look at how the words that you're using and determine how common they are in everyday language. It has an algorithm that sort of looks at each word and ranks it as jargony or not jargony based on how frequently it's used in everyday language. And so let me just give you an example. As I mentioned, my scientific training, my PhD is in immunology. And so, this is a title of a paper or a poster or a project that I might have presented back when I was doing my immunology research. This is kind of what I worked on, right? So thank you, Hannah, for doing that. So I might have had a title like this: the murine LPR mutation results in spontaneous autoantibody production due to premature termination of transcription of the gene encoding the apoptosis signaling receptor FAS in autoreactive lymphocytes. Now, that's a title that you might see on a poster at an immunology meeting, but if you weren't an immunologist, that would have no meaning to you whatsoever, right? And if you hit start on this, you can just get a sense of how full of jargon that is, right? Everything in red is highly jargony, and everything in orange is sort of mid-range jargon. But as you can see, almost every single word in that sentence, in that title, is jargon, right? That's incomprehensible to people who aren't other immunologists. So I decided, okay, let me try this again, and I'm going to try to come up with a more accessible way to say this. So here's what I did. Instead of things like murine to refer to mouse, I said rodents, okay? Instead of lymphocytes, I said T cells. Instead of apoptosis, I said programmed cell death. So, it's a little bit more accessible. When we run this now, sorry, my mouse is going crazy. My murine device here is going crazy. So I said mutations in rodent T cells prevent programmed cell death resulting in autoimmunity, right? And what we get when we run that is you can see way less jargon, right? First of all, notice it's a lot more concise. It's a much shorter sentence than the first one. It's going to fit much better on the top of a poster. And there's fewer jargony words in there. There's only one word that's highlighted in red, autoimmunity, and just a few that are in orange, mutations, rodent. So, they didn't like murine at all, but rodent still is something that, is a little jargony according to this algorithm. T cells maybe a little bit better than lymphocytes, but still a little jargony. So we're getting closer, but this isn't still fully accessible. So I decided I'm going to try one more time and let's see if I can do a better job this last time. Here's what I came up with for my third effort. Zombie white blood cells make mutant mice attack themselves. All right. Now, is this a very sciencey sounding title? Certainly not. But, for anyone who's not an immunologist, this is going to not only be more comprehensible, it's even shorter than the last sentence, but it's also got even less jargon in it. Notice there's no red words this time. And I would say that the words that are highlighted in orange, zombie and mutant and mice, they're highlighted because people don't use them a lot in everyday language. But these days, you're going to find almost anyone over the age of 10 is going to be familiar with words like zombie and mutant. And of course, everyone's going to know what a mouse is, right? So it's about making things more concise. It's about making them, less jargony. But also, you notice there's a little bit more flair in this, right? There's a little bit of an effort to sort of grab people's attention and lure them in through sort of something that's maybe a little shocking, but sounds like it might be exciting, right? Something you might see on, maybe remind people of The Walking Dead or something like that. So, it still conveys the same basic message, but it does it in a more concise way with fewer jargony words and more of a stylistic flourish to it, all right? And so let me give you some examples. I want to do some more audience participation here. I'm going to give you some titles. These are actual titles of work that was published in science journals. And I would like you to de-jargonize them. So remember, be concise, be jargon-free, and try to, if you can, maybe use a little bit more, at least accessible language, if not maybe a bit more of a stylistic flourish in it. So the first one here, the headline, the title was Correlation Found Between Intestinal Microbiota and Dysthymia, or Persistent Depressive Disorder. All right, now if we put that in the de-jargonizer, it'll be loaded with jargon, I guarantee it. How would you say this in everyday language? How would you de-jargonize this title to make it more accessible? Anyone want to share their thoughts in chat on that one? This requires a bit of thinking, so I'll give you a minute here or so to come up with your answer. Okay, relation between gut microorganisms and depression. Good, that's a good start. Definitely simpler, less jargon. Gut pathogens cause depression. Okay, good. Connection found between stomach and depression. Great. We do want to be a little bit careful. Your poop and your mood are connected. Wonderful. I like that one. So things like gut, there's one that was like gut pathogens cause depression. We do need to be a little bit careful when we try to come up with more accessible titles because there is a correlation found, right? So that's an important thing here. And so saying this causes that, we're sort of getting at this, this traditional misunderstanding that non-scientists have of the relationship between causation and correlation. So you need to be a little careful about that. But you guys are doing a really great job with this. Link found between gut health and depression. Wonderful. So what did I come up with? Something very similar. Gut bacteria linked to depression, right? So I tried to avoid cause because of the word correlation, but I said linked to depression. And I think that's good. Some people say bugs as a way of referring to bacteria. I would caution you to be a little bit cautious or to be a little bit careful about that because that's jargon actually, right? If you're a microbiologist, you refer to bacteria as bugs. But to the general public, if you say bugs, they think of insects, right? So, I think gut bacteria, or, you came up with a bunch of great ones, link found between gut health and depression, wonderful. All right, good. Good job. Let's try that again with another one. I actually love this title, even though it probably doesn't mean much to someone who's not a solid state physicist, but I just love this title, but let's simplify it anyway. A super chilled molecular gas reaches quantum limits of coldness. I'm not a physicist. I don't really know what that means, but I have a guess. But try to translate that one. How would you say this in much simpler language? A super chilled molecular gas reaches quantum limits of coldness. Cold gas reaching Kelvin temperature, good. Although Kelvin, again, if you haven't taken chemistry or physics, you might think, that you're talking about a person named Kelvin, which I guess in a sense we are, but ice cold, right? Or even colder, maybe, yeah. I mean, ice, right? There's lots of different types of ice. What else? Air so cold it can't get colder. Good, excellent. Yeah, I think I had something really similar. I had these gases can't get much colder. There you go. Like nice, simple, accessible language. Cold gas reaches temp you can't believe. There you go. Yeah, excellent. So yeah, you get the idea, right? It's about using accessible language, being more concise, getting rid of the jargon, but still trying to get their attention. All right, let's do one more. Deforestation tied to variations in human disease dynamics. All right, now a lot of these are words that we've probably heard before, but you put them all together like that. And for someone who's not an ecologist or an environmental scientist, this is going to feel very jargony. So how would you translate this while still, and make it more concise, get rid of jargon while still, getting people the message of what this basic story is about? Deforestation tied to variations in human disease dynamics. Diseases brought by disturbed ecosystem. Good. I like that one. What else you got? That's a good one. Yeah. Clear cutting linked to human disease spread. Wonderful. Great one. Yes. And I like that you did link to, right? Because, you weren't saying clear cutting causes because the original headline said tied to. Any other thoughts? Fewer trees linked to changing diseases in humans. Yeah, although that one, that's good, although that one could maybe be misinterpreted because that might be read as before lots of trees were linked to changing diseases in humans and now fewer trees are. You know what I mean? So it's a different way of interpreting that. So you need to be a little bit careful with the wording on that, which is why sometimes we test out titles and headlines with other people to see if maybe they catch something that we missed. Plants contribute to decline the risk of developing disease. Good. Here's what I came up with. Cutting down trees can affect our health, right? I kept it as simple as I could be, right? But you're all doing a wonderful job of this. And I think you're really, sort of getting the idea here, which is make it more concise, trim out some of the jargon, but still communicate the message, hopefully in a way that's engaging enough that people realize why it matters to them. Remember what I said a number of times. I'm going to say it again. The point of science communication is to get people to understand what you do and why it matters to them. So you have to keep that why it matters to them piece in there as well. All right, let's just, we're running out of time and I want to do one more quick little activity with you. So let's look at the next commandment from Tim, which is, he says, read lots of different things. And he gives you a list of all these different things that you can read, Dickens and poetry and Marvel comics, right? Look at the wonderful things you can do with words. And the point here is that you want to tell a story, right? Even with a title or a headline, the goal is to make it more concise and more accessible, but also to tell a story. People respond better to stories than they do to just a list of data, right? And so let me give you an example. This isn't a title. This is actually an opening sentence of an article. But this is about the creature you see in front of you. He's called Tiktaalik. You might know this. Any of you who are evolutionary biologists or paleontologists might recognize this drawing. It was discovered as a fossil, considered to be one of the sort of missing links, one of the earliest four-legged land roving animals. And it was discovered by Neil Shubin, the evolutionary biologist. And when it was written about in a science journal, here's how it was described. The evolution of tetrapods from the Sarcopterygian fish is one of the major transformations in the history of life and involved numerous structural and functional innovations, including new modes of locomotion, respiration, and hearing. Now, Neil Shubin's a wonderful writer when he writes for the public, but he was writing for his scientific peers, and that's a very sciencey way to write that. How did The Guardian cover it when they talked about this finding? They said, the fossilized remains of an ancient beast have revealed how prehistoric life hauled itself from the water and took its first unsteady steps along the path that led to our four-legged land animals. You see the difference there? The language is more accessible, but also they're telling a story, right? There's drama in this. This is, you could picture, this happening in a movie rather than just sort of looking at data on a screen, right? This is a storytelling piece that makes it really compelling. So, anytime you can sort of tell a story, and when you're doing this, that's going to be more compelling. So let's do one more example. We have a few minutes left. This was an article in The Verge, which is a news website that has science and technology news. It has other news as well, but covers a lot of science and technology for a very general public audience. And here's the story. This is directly from the story. They talk about a team of engineers from Harvard who created a robotic octopus that involved putting liquid silicon into a mold, adding 3D printed legs, and then there was a controller that controlled the robots that shunted hydrogen peroxide fuel through a reaction chamber to convert the liquid to a gas and water vapor. The gas inflates the legs through teeny channels running from the body and makes them wiggle. Vent orifices were created to prevent accumulation of gas. All right, so that's a very sciencey description of what they're doing here. But I want you to write the headline for this article, okay? So craft a short, concise headline that communicates what they did and does it in an interesting, eye-catching way, and summarizes what happened in this research, okay? So I'll give you a couple minutes for that. And then when you come up with a headline, you'll notice the headline on the screen, I blanked it out. I'm going to show you the headline they actually used in a minute. But first, I want you to try to come up with the headline in a very concise, jargon-free way that still grabs people's attention. Describe what happened in this work that these Harvard engineers did. I'll give you a couple minutes. This one's a little bit more work than the previous one, so you need to absorb more information. So take a couple minutes and then let's see what you got. And as soon as you've come up with a catchy title for this article, go ahead and put it in chat and we'll see what you all came up with. Harvard engineers craft living robot octopus. Wonderful, very concise, straight to the point. You condensed a whole big long paragraph into just, 6 words? You even fit Harvard in there. I always point this out to my students that usually when work is done at Harvard or Yale or Princeton or MIT, that makes it into the title. Most other institutions, it doesn't make it into the title, but if it's done at one of those universities that everyone has heard of, then typically they'll throw that into the title because they know that grabs people's attention. So that you did a good job there of sort of building on the cachet that Harvard has as a known brand name across the country and across the world, really. So that's great, Billy. Thank you. Other suggestions here? Anyone else have a contribution to this? I expect to see them rolling in any second. Here we go. A robotic octopus is brought to life. Great. There's a storytelling piece there, sort of a dramatic flair to that. I like that a lot. Let's see what else people come up with. By the way, when I did this before, someone in their headline, they came up with the following. I'm going to type it in chat because I just love this. They combined robot and octopus into Roboctopus, which I just thought was fantastic. I absolutely love that. Any other contributions to this? Any other titles that you can share with us that you came up with? This one's a bit tougher. It's taking people longer. Well, I'm going to encourage you to keep putting them in there, and I'll take a look at them. But since we're almost out of time, I want to show you the title that they actually went with for this article. It was "This Adorable Robot Octopus is Powered by Farts." All right, so clearly they were going for sort of the the third grade humor level here, the puerile humor. Sorry, the sort of bathroom humor. You don't have to take that approach, but that's what they were going for with their audience. But you get the idea, right? It's a way of using just a few words to grab people's attention. Like it or not, whether you consider it crude or not, it may not be your style, but when you mention things like poop or farts or anything like that, it definitely gets people's attention. So again, it's about being concise. It's about trimming out the jargon, and it's about grabbing people's attention and letting them know why they should read this article, why they should care about it. So, my final piece of advice to you, along with all the other things I've been saying, is and this gets back to Toby's question at the very beginning, which is, should you go for sort of witty and pithy and clever? And my answer then, it's the same as my answer now, which is it's up to you and your personal style, and it's about knowing who your audience is. And again, if you're, maybe a grad student and you have to run this past your advisor, and you don't think that your advisor is going to go for humor or for, that type of approach, then, know your audience and maybe avoid that. But, if you're doing your own poster or giving your own talk and you want to be clever or creative with the title, I encourage you to do that. And here's these are actual science talks that I've found, the titles of out there that I really loved. And I think were really clever. So guess who's not coming to dinner? Evaluating online restaurant reservations for disease surveillance. Or how about this one? Nifty ways to leave your lover. The tactics people use to entice and disguise the process of human mate poaching. I mean, that's so clever. Of course, it's referring to a song from the 70s, 50 Ways to Leave Your Lover. And so you also have to know your audience, because if you're talking to a bunch of grad students, that reference might be lost on them if they don't know that song. But for someone who knows the song, 50 Ways to Leave Your Lover, they're going to think that's really clever. Or how about this one? You probably think this paper's about you. Narcissist perceptions of their personality and reputation. Again, a reference to a song, an even older song, right? You're So Vain. But again, if you know that song, what a great talk title this is. I would go to see the talk just to reward the person for coming up with that title. I love this one too. I was pretty into metal when I was younger. So head and neck injury risks in heavy metal. Headbangers stuck between a rock and a hard bass. How clever is that, right? Or this one, children and mini magnets, an almost fatal attraction. Okay, now that might be right on the edge. Maybe some people don't think it's funny to make jokes about kids swallowing magnets, but still, I think it's pretty clever, right? So, it's about, like with every other form of communication, it's about developing your personal style and what you're comfortable with, and knowing who your audience is and what will work with them. And so I'll just end here. We're right at the top of the hour. So I'll end here with one last commandment from Tim, which is, no one will ever complain because you've made something too easy to understand. So with that, I want to stop, and I want to thank you all for participating. I know there's a lot of audience participation here. And so thank you for being engaged and participatory. I'm happy to stick around for a couple minutes if people have questions. And again, I'll just one more time, I'll put my email address in the chat. So if you want to reach out, if you want the slides, or if you just have questions about science communication in general, please feel free to reach out. Other than that, thank you for your time and your participation, and good luck and have fun with your communication. And I hope you enjoyed the workshop and got something useful out of it.
Jory, thank you so much. That was such a useful workshop. I mean, it's such an important topic. I think it's probably not considered enough. You know, oftentimes really thinking about your audience, and this is great information, and you presented it so well. Thank you.
Absolutely. Thank you all. And like I said, if people have specific questions and they don't want to ask in front of the whole group, I'm happy to stick around for a couple of minutes and answer additional questions. Otherwise, good luck. Have fun. Stay healthy. Han Hu, did you have a question? Your camera came on, so I thought maybe.
No, I just want to see thank you in person, in face, this type of person.
Oh, well, I appreciate it. Thank you very much. I appreciate that.
Have a great day. I appreciate this talk. It's nice.
Great. Have a great day.
You too. Bye.
Bye-bye.
Jory, I will tell you, I've dealt a lot with the medical profession the last couple of years with both parents having some catastrophic situations. And I have, even before I started this job, people do not know how to communicate. These doctors don't know, they're not saying the right words, you know, and so this is something that is very dear to me, and I think it's a really important thing to do. So.
Yeah, well, you know, the problem is that whether it's medical school or graduate school, science communication training for a non-expert audience is not a requirement. And a lot of times it's not even an option, you know? I mean, I teach these courses at Duke, but they're elective courses, right? So no one's required to take my science communication course. I will say that it fills up every semester. There's plenty of grad students who want this information, but nobody's required to take it. And a lot of schools, they don't even offer a science communication class. So, you know, it really is, I mean, my vision, my dream would be that every scientist and every clinician, every doctor would be required to take a science communication class as part of their training. But we've got a long way to go before that happens. But I think it would be important, you know?
Well, listen, if I can do anything, you just let me know, because I am so, this is my crusade. So it's baffling to me that it's not a part of everybody's curriculum. But
yeah,
because I mean, if you're going to do something, you need to be able to tell people about it. I mean, or else it's negligible what the good is, you know.
Yeah, absolutely. And I think, you know, the last couple of years more than ever, people are starting to see the importance of being able to communicate science effectively and clearly so that people understand it, so that you avoid misunderstanding and misinformation.
I feel like we have seen that apparently people hadn't really been taking that super seriously. Even places that we thought had, you know, even like our government resources and everything, I'm sure people were thinking, we're worried about how audiences can figure this out. And then COVID, we were like, oh no, they're not doing it.
Yeah, well, so, you know, it'd be interesting to see if one of the things that comes out of the pandemic, I mean, there's a million things that we need to change and improve on that we've discovered, you know, over the last 2 years. But it'll be interesting to see if making more of an effort to help scientists and physicians, you know, empowering them to communicate more clearly and effectively is one of the things that rises up as a higher priority. I hope so, and I think that we see how important that is. But you know, we'll have to wait and see. But anyway, you know, hopefully this was useful to your audience. And
it was useful to me. I think it was useful to everybody. It was really good. It was really great information.
Absolutely. Well, I think I don't know if any of the other people on are waiting for questions, or if maybe they fell asleep at their computer or something. But I guess I'll maybe disconnect if there are no other. We're
gonna go ahead and close this meeting out. I guess. Thank you very, very much.
Yeah, thank you for your help. Have a great day. Bye-bye.
Bye. Bye, everybody.